All right, let's do another one. Okay, so welcome everyone to this video. I was thinking if I should put this together or not, but I think it's worthy. It's a difficult topic to discuss and a very frustrating topic for students when they're just beginning to deal with formulas and then rearrangement of formulas. The reason is because you can take a formula and honestly manipulate it several different ways. So for a student, when you're solving and let's say you've rearranged for some variable, and after you rearrange it, you take a look at whatever answers your teacher maybe has provided you, or maybe the textbook or something like that, and then you noticed, that looks different. And in fact, you might be completely correct. It's just that the answer that they have written out is just in a different form, but they're identical. So I wanted to go through several examples here, hopefully reduce some of that frustrations. But I know personally, when you're starting, it will be very difficult to deal with these. Okay, so I want you to know that it will be hard, and you're gonna get probably frustrated, and that's okay. You got to kind of grind through it and then slowly see. And with more and more experience, which really, that's kind of how learning works. You need quite a lot of different experiences and practice to finally start catching on to these. So let's take a look here. I have numerous examples, so about 6 of them, in formulas that maybe look slightly a little bit different, but they're actually the same. And I'll try to talk about what can happen and the variations that could happen when you're solving and rearranging. So now I did a full video on rearranging formulas, and I'll put a link, I guess, up above for you if you want to take a look and see how the process of rearranging works. In this video, I will just concentrate, kind of on the little tricks that you need to think about so that you don't get caught up thinking that maybe you did something incorrectly and yet you did. All right, so let's take a look. So I am going to kind of start with question number 1 here. Let me bring this down, and I'm going to try my best, honestly, to try to show you, what can happen. So on the left-hand side, you have a formula which is for t, and then on the right-hand side, you also have a formula for t. Now, they have the same variables, so notice they have d, d0, okay, and then v. So the variables are the same, but the formulas look slightly different. So let's imagine that, you came along and basically this was your answer, and then you look, at the answer key that maybe your teacher or prof or whoever has provided you, and you look and you see, oh, well, that's not what I got. And so here is the concept that you have to be able to manipulate your formula to try to kind of look at, okay, that it looks like the answer itself. Both of these are correct, all right? So both of these are correct, okay? So they're exactly the same formulas. Now, in order to get the formula which is on the right-hand side, so what this person has done, whoever maybe has written this out, so you have this v in the denominator. Now, in the denominator, what happens is you can factor out that v. Okay, so for instance, so what you have is, you can do something like this. So d minus d0, really, you can think of it as 1, and inside of the brackets you have d minus d0. So that shouldn't really throw you off in any ways, because when you multiply by 1, it's exactly the same. And now notice that, this v that we had in the denominator, okay, so this v is being placed, okay, right there. And here, okay, just by fractions, I could have just simply written this as 1. And notice that if you take, 1 and you multiply it by this bracket, all right, so, well, you're going to get this right here, which is in the numerator, all right, so that's right there. So that's really this. So that 1 in front is redundant. And then if you take your v and you multiply it by 1, really, because this is just fractions, right? So when you're multiplying two fractions, you multiply numerator times numerator and denominator times denominator. And if you do that, you're going to get exactly this equation, right? So it's kind of thinking that you have this over 1. All right, so you have 1 times this, which is going to give you d minus d0, and then all over v times the 1, which is just v, which shows you that these two rearrangements are actually the same. So you can certainly do that. So that's question number 1. All right, so both of these are the same. So here is another question. Okay, so this one is maybe, I don't know if it's going to be more frustrating or not, but let's take a look at it. Now, it's going to be difficult for me to provide you with every single variation here when you're dealing with formulas. So, I mean, I kind of just picked, several of them that you might run into, and then, just to get you in the thought process that you want to be able to match, okay, something else. So again, so you look at this question and you see that, let's say you came along and maybe, again, you got this one. Or maybe you came along and, you got this one on the right-hand side and your answer is the one on the left, or vice versa. So how do you see that these two are the same? Well, if you start from the left-hand side here and you want to go to the right-hand side, so if you want to match it to this direction, so this again goes back really just to understanding fractions and finding common denominators. So what we have done is we wanted to have a common denominator for both of p. So remember that for this is really just t over p minus, and 1 can be just written as 1 over 1. So if you want to be able to find a common denominator between p and 1, because those are your two denominators, well, you can just choose the denominator of p, right? And so for that reason there's nothing to do with t over p. It's already over p. But this 1 right here, okay, so this, if you make the denominator p, so this is going to be the same thing as writing p over p, because p over p is just equal to 1, right? And that's what this was. Okay, so that's the 1. But now when you write it that way, so what you have is you have t over p, so that's coming from right here, minus p over p. And now because they have the same denominator, right, so this is nothing else but t minus p all over p, which looks exactly like this. So that's the frustrating component, and you have to slowly start thinking about these. And that's why it's so important, when you're building up your foundations with fractions, everything kind of starts tying in together. And then you have to be able to take those tools you've learned and then apply it, to slightly different problems. But they're really the same things. So this is an example that you would see that. All right. And then, of course, you can go in reverse. You can start from here, and then you can write this as this. And, of course, you should see that p divided by p is just equal to 1. And then you'll get the left-hand side back. So that's kind of the second example that you have. All right. So now let's take a look at another example. So this one is interesting because it's not very difficult, but it does come up because sometimes, when you're dealing with formulas, depending on how you rearrange things. So let me just paste this back. This one hopefully will be the shortest one. So number 1, what you're looking for is you want to make sure that all the variables are the same. So let's say this is, BMR, and then it equals to, now you may not even know what this formula is for. It doesn't really matter, but if you start learning, this one's actually from health or fitness if you want. It's the basal metabolic rate. It's how many calories you have per day, depending on your body and if you're male or female, or your structure within in terms of your mass. But that's kind of irrelevant. Okay, so the relevancy here is, are these two things the same? And so notice that what we have here in this situation is, we have really just a bunch of terms on the right hand side. So here are my terms, and then of course I have the terms here, but they are written in not exactly in the same order. And that's again just something that I want you to know, because if you look and you rearrange a formula, you might rearrange it. Let's say, I don't know, this is something you might get, and then you look at the answer and it looks like this, and right away, because you see that 6.25h right here in front, you might be thinking like, oh, am I wrong? And sometimes you might ask, is this correct? Well, the idea is you want to see, okay, if all the terms are lining up. So your goal is to take, for instance, in this case, you can rearrange this formula so that they look identical, and just look at the signs, right? So for instance, this 6.25 you also have here, and they're both positive, all right? So that's something that you want to be able to see. So of course these are the same. And then you take a look and you have 5a, subscript y, and you have that here, and they're both negative. So far so good. And then lastly, you have an s, which is positive, so you see that here. And then the final thing is, you have the 10, which is positive, and you have the 10 here. So the difference between these two formulas or rearrangements is just how they put their terms. And you can think back of this as just saying, if you write 3 plus 5 minus 2, the order of these actually doesn't matter, right? So you have three terms. You have 3, the 5, and the 2, and it just turns out to be a subtraction there. But you could have written this as 5, plus 3 minus 2, and that your answer would have been the same. 3 plus 5 is 8, minus 2 is 6. And in here, 5 plus 3 is still 8, minus 2 is still 6. And you could have even made this, completely jumbled up, meaning that the terms, you could have just said minus 2, plus 5, plus 3. As long as the signs are the same, right, the additions and subtractions that you have, you're still going to get exactly the same answer. And that's what I'm trying to point out to you with these formulas, that they don't always look exactly how you rearrange them. The answer that you might look slightly different, but you should know how to put it into that form. And then that's just manipulating those formulas. So for instance, in this one, so you have, here it says negative 2 plus 5, right, which is 3, and 3 plus 3 is still 6. So notice, it didn't really matter how we wrote these out. They still gave us the same answer. So that's what I wanted to point out in this formula right here. So that was question number 3. Let's take a look at question number 4. Okay, and question number 4 and question number 5 are actually they deal with exactly the same thing, and that's kind of having negatives, okay, within here. So here is another formula or an equation. We have x, y, a z or a z, and then c. But on the right hand side it looks different. It looks like, oh well, it's z or z minus 3y divided by c. Where did this negative go? Okay, so this is another kind of indication of you understanding how negatives work. So for instance, if I wrote and I gave you a fraction, okay, so if I gave you a fraction and it said negative 4 plus 5 divided by, okay, let's say negative 1. You should know and you should understand that really, what this is this is just saying that. Okay, so plus 5, okay, and minus 1, because that's the denominator. And when you do that, so notice that the negative from the bottom can disappear because you can start, okay, bringing it up into the numerator. So notice this negative and this negative can cancel, and this would have been just 4 over 1. And now you could have taken this negative and, brought it right here. So the positive and the negative right there, it equals a a negative. So this would have been minus, 5 over 1. So if you rewrote this, this would have been 4 minus 5, all over 1. Okay, and so if I'm going to take this, let me, show this to you here. Notice they look different, right? They look different, these two, but they're actually the same. So it's a matter of understanding that the negative from the bottom can be actually brought to the top by canceling these units out. So if you have a negative in the denominator, and there's just one number there, then you can cancel those. So the negative and the negative becomes positive, and then the negative and the positive becomes negative. And in formulas, we do this quite often, actually. Okay, so I'm going to kind of erase this out. You can, of course, go back in the video and rewatch it, but I just want to bring a point here, because what you have is a lot of the times, not always, but some teachers or profs or whoever, engineers, anybody, scientists, they don't always like to have a negative in here. So what they'll do is, okay, they'll say, okay, so I have a negative at the bottom, okay, this is positive, okay, and then I have a negative here, and this is negative. So, they will just cancel those units. So here, because this is positive, so a positive and a negative is equal to negative. So this is going to be negative 3y. And then here, the negative and the negative is going to be equal to a positive z. And then that negative at the bottom has now disappeared. And you have that. And so in order to see that these two are equal, so notice that all they have done is, instead of having, negative 3y in front, okay, they just swapped these two. So they swapped this, okay, with this. So they wrote z, which is positive z or positive z, minus 3y on top, and then they just kept the c at the bottom. And then that's how they got this. So that's going to be a frustrating part sometimes when you're working this out and when you're seeing this. And you have to be wary of this, that when you finish your rearranging of a formula, it may not look exactly the same as the answer. You might have to manipulate it to look like the answer. All right, so that's another example of this. I hope that this made a little bit of sense for you. And it will be hard. One thing you have to realize that, like you might have to look over it and then see it and then maybe ask questions if you ever get an opportunity to do so. I mean, you can certainly put comments below. I'll try to help as best I can, unless I get super overwhelmed with comments from all the videos. Okay, so here, that was question number 4. So here is another question which does exactly the same thing. So I just want to show you that, this happens actually quite frequently, when we might have to kind of just rearrange things. So notice here, so what you have is there is a negative at the bottom. Okay, so for this example. And notice that here there is, that negative is gone. So that's what they've done, is they basically have taken this out. So what they've done is this. They've said, okay, so I have df over negative v. All right, and then they have negative di over negative v, and then negative v tf. So I'm just writing it as in fractions, like you would normally a fraction. So what they have done now is they have combined this, okay, and the positive there. So notice, positive and a negative, because it's division, is going to give you a negative, okay, and that's where this negative came from. So notice the df, all right? So the df, so this is df, and this is df, all right? So the sign has changed now. Now here, so for the next one, we have a negative and a negative. Well, negative and a negative is a positive. So notice that's why the di here became positive. All right, and then finally again, so negative and negative becomes positive, and that's what they have done there. And of course, again, they rearranged them, So notice VTF here was at the end. Okay, now it's in the front, but it is positive. That's what you have there. All right, so this is what you have within here. So I'm gonna clear this out. Okay, and let's walk through it again. Okay, just so that you can see it. So what they're doing is the following. So they're taking the sign, so they have a sign of negative, and they say, all right, what is the sign there? Okay, and then now they're gonna say, oh, okay, so I don't want the negative in the numerator, so that, okay, negative and positive, okay, is gonna be negative df. All right, so that's that. Now they take, okay, this sign and then the negative, so they have the negative and the negative, so now this becomes positive. So that's that. And then again, so finally they have this negative and this negative, so again it becomes positive VTF. And at the bottom in the denominator, okay, that just became positive now because you got rid of that negative. But you have to distribute it through every single term in the numerator. You can't just distribute it through one. That's the important part. And now in order to get it into this form, well, they've just rearranged it. So notice that they just said, okay, let me put VTF first. So that's this, it's positive, plus DI, so that's second, and then they put the negative. And most of the time they may do this because they don't like to have a negative in front there. But these are identical. All right, so that's another, I guess, you know, a trick, or I mean, it's not really a trick. It's just a matter, again, of experience and understanding this. So that was question number 5. So now the last one, I guess there was one more, and this one, you know, hopefully we'll try to finish this one down. So let me put it all the way below. So these definitely don't look alike, right? So you have T is equal to, and then S over P minus 1 is equal to R. You know, so how in the world do these two things, you know, kind of look the same? You know, does it even make any sense? So let's take a look and see, you know, what happens. So first, you know, what I'm going to try to show you is let's take the numerator on its own. All right, and if you take the numerator of its own, it basically is exactly the same as, you know, this example, which was here, example number 2. All right, so that's kind of what's going to happen. So we're going to take this, all right, and if I only work with that, so I have S over P minus 1. So based on example number 2, and you can kind of rewind the video if you like, okay, you should know and see that, well, we can say this is S minus, you know, this is going to be P all over P. That's what this is going to be equal. So I'm not going to repeat the same thing I did for example 2. All right, so we're just finding a common denominator between, and that 1 has just simply changed to P over P, which is 1. So now if you have that, so that's my numerator, right? Now my denominator in here is R, but it is, so notice there is a division there. So, you know, I am dividing here. Now from fractions, you know, you remember that division of fractions is multiplication by the reciprocal. All right, so here is the reciprocal. And now, you know, you can see, so what you have is you have S minus P, so you have this thing, multiplied by 1. Well, if you multiply it by 1, it's going to stay the same. So that's how we got this right there. And then you have P multiplied by R, which is just PR. Or you might write it as RP. Typically, we try to keep it in alphabetical order. So that's how you actually came up to that. And that's what I mean with the frustration. So you're going to run into it. I do want you to know that it's hard, especially when you're starting these. And, you know, feel free if you want, you can leave a comment. I'll do my best I can to try to answer them if there are any comments. All right. So thank you for watching. I wanted to share this with anybody who might be interested. You know, if it helps even just one person somewhere in the world, then I guess it's done its job. All right. Okay. So take care, everybody. Okay. Stay healthy, stay safe. Bye.